Within our next section, we are going to look at properties of exponents. So in each one, we actually will somewhat discover it for ourselves, and then we'll pull that together and talk about what that property really says. So in the activity, it says to write the product of the two powers as a single power, not evaluating them. So look at the sample. It tells us 3 to the 4th times 3 to the 3rd. Well, remember, exponents really tell you how many copies of the base you have, how many times to multiply the base by itself. So 3 to the 4th means I have 4 copies of 3. I'm multiplying 3 by itself 4 times. So notice I did 1, 2, 3, 4. 3 to the 3rd means I'm multiplying 3 by itself 3 times. So there's 1, 2, 3. Well, again, it says to write it as a single power, not to evaluate. So I'm not just going to press buttons on my calculator, 3 times 3 times 3 times 3, and see what that equals. I'm writing it as a power. I have 1, 2, 3, 4, 5, 6, 7 copies of 3. So 7 times I'm going to multiply 3 by itself. Going to do the same thing for those 4 examples. So 2 to the 2nd would be 2 copies of 2, and then I have 3 copies of 2. Well, how many copies of 2 do you have total? 1, 2, 3, 4, 5. So that would be 2 to the 5th. For number 3, 4 to the 1st means 1 copy of 4, and then I have 5 copies of 4. So there's 1, 2, 3, 4, 5. How many total then do I have? 6 copies of that base 4. 5 to the 3rd means I have 3 copies of 5, and then I have 5 copies. So how many do I have total? 3 and 5. I have 8 copies of 5. And the last one, even if we tried to use our calculator, we couldn't. That x squared means I have 2 copies of x. So I would have x times x. Then 6 copies, 1, 2, 3, 4, 5, 6, a total of 8. Hopefully you did notice along the way, well, that's a lot of writing and a lot of counting. Hopefully we have a faster way of doing that, and we absolutely do. If you haven't yet noticed, notice what happens between the exponents that you start with and the exponent that you end with. I have an exponent of 4, 3, and with 7. 2, 3, and with 5. 3, 5, and with 8. You do add those exponents. But notice we have to make some observations here as well. You are multiplying in between. The bases for those exponents are the same. So when multiplying numbers with the same base, we are able to keep that base the same and add exponents. So that's exactly what this first rule tells us. And notice what the name of the property is, the product of powers. Product means you're multiplying. Powers means it's a base raised to some exponent. So when you're multiplying powers having the same base, we will add those exponents. So in general, that's what our property tells us. A to the m times a to the n, my bases are the same, therefore I can then add those exponents a to the m plus n. Again, the 2 keys there, it is multiplying, the bases are the same. Keep the base the same, add those exponents together. Discovering our next rule. This is the power of powers. So notice I have 2 exponents. Here's a power, and then the whole thing together is a power. Well, this means, same sort of thing, 3 copies of 3 squared. But then 3 squared is 2 copies of 3. So I have each one of those. Well, then I have 1, 2, 3, 4, 5, 6 copies of 3 total. For number 1, I have 4 copies of 2 squared. So there's 1, 2, 3, 4. So if I expand that, then I have 2 of each. So there's 2, 2 more, 2 more, and 2 more. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 2 to the 8th power. For number 2, I have 3 copies of y to the 3rd. So y to the 3rd times y to the 3rd times another y to the 3rd. Each one of those y to the 3rds is 3 copies of y. So there's my first one, second one, third one. How many do I have total? There's 3, 6, 9. That is y to the 9th. Same sort of thing over there in number 3, 2 copies of 7 to the 3rd, and then that means 3 copies of 7 each time. Therefore, I have 6 total copies of 7. Last one, x to the 4th squared, so I have 2 copies of x to the 4th, but x to the 4th means 4 copies of x. There's the first one. There's my second one. How many total? I do have x to the 8th. So in general, so we don't have to write out all that. My hand's hurting already. How can we get from original problem to then that final answer? Notice that the base stays the same. So what happens to those exponents? 2 and 3 getting me to 6. 2 and 4 getting me to 8. 3 and 3 to 9. If you notice that you are just multiplying those 2 exponents together, you would be correct. So when you have the power of a power, you multiply those exponents together. Again, you are going to keep that base the same and multiply the exponents. So again, notice base stays the same. I do multiply those exponents together. So that is exactly what we found through that activity. The last one is now the powers of products. So that means we're going to be raising a product, a multiplication problem, to an exponent. So 2 times 3 to the 3rd, instead of actually multiplying this and get 6, I know that that's what that is. Instead, we're going to say that this is 3 copies of 2 times 3. Well, if I want to write it as the power of 2, or excuse me, the product of 2 powers. That means I'm not just going to do 2 times 3, 2 times 3 times 2 times 3. No, pull together your like terms. I have 3 copies of 2, then I have 3 copies of 3. As the product, multiplying 2 powers. 2 to the 3rd is 1 power, 3 to the 3rd is the 2nd power. So in number 1, I have 2 copies of 2 times 5. My first base is 2, and I have 2 copies of it. My second base is 5, and I also have 2 copies of that. In number 2, you might look at this and say, well, wait, what's 6a? 6 is multiplying a. We have 4 copies of that. So there's 1, 2, 3, 4. The one base that I see is 6, so I have 1, 2, 3, 4 6s. The other base I have is A. There's 1, 2, 3, 4 copies of A as well. Jumping over there to number 3, 3 copies of 5 times 4. There's 1, there's 2, and there's 3. The 2 bases, 5, I have 3 copies of 5, and I also have 1, 2, 3 copies of 4. Number 4, very similar to number 2, 3x really is 3 times x. I have 2 copies of that, so 3 times x times 3 times x, 2 copies of the base 3, and 2 copies of the base x. Again, our goal is to not have to do all that writing, way too much. There's a property that makes that a lot simpler. What do you notice? Each one of the original bases, the original factors, it's a multiplication problem, receives that exponent that's on the outside of that set of parentheses. A lot of times I will hear students refer to that as distributing the exponent to the 2 factors. That's fine if that's how you want to think of that. So to find the power of a product again, that's key there, we are multiplying. Find the power of each factor. So that's each number within the multiplication problem. I've done that a few times, not of factor, how about of each factor? And then we will multiply. So again, it has to be multiplication inside that set of parentheses. Each factor, the factors are 2 and 3, gets that exponent of 6. Notice, again, there is no power of a sum or difference. You cannot distribute that power to addition or subtraction. Cannot stress that enough. So if my original problem was x plus 2 to the third, I cannot, absolutely cannot distribute that and make it x to the third plus 2 to the third. Those are not equal. In the future, we will find out how we would actually simplify x plus 2 quantity to the third. Distributing that exponent is not correct. It has to be multiplication inside the set of parentheses to be allowed to distribute that exponent through. What if, though, if I do have a product, if I have 3x squared and I want to raise that to the third? This is multiplication. This is really 3 times x squared, that quantity cubed. This is a product, so I would want to distribute that exponent to both. So I would have 3 to the third times x to the, well wait, the x already has an exponent on it. What do I do between the 2 and the 3? Well, this is really x squared to the third. Look back at the last property that we discovered. We said when you have the power of a power, this means I have 3 copies of x squared. And then each x squared is 2 copies. That makes 6 copies. You do multiply. So in this property, we can actually pull the power of a power property along with us. If a base already has an exponent, you are multiplying. Well, technically, every base, every factor has an exponent. What exponent is really here on 3, even though I don't see it? It absolutely is 1. 3 times 1 is 3. So even though you don't see exponents, remember, there's 1 copy of that base. If you see that base there, there's 1 copy of it. So it does have that exponent of 1 being understood to be there. So those are our 3 properties. Some examples, I'm not going to read through every single one of those. You can look through them just to point out what property they are. This is the product of powers. I'm multiplying powers that have the same base. Add those exponents. Power of a power, we multiply. This is the power of a product. Multiplication problem inside. Distribute that exponent to both of those factors. We only have 2 factors here in this 6 times 5. However, here we have 3 factors. You're doing the same thing. I could have 20 million factors. That exponent gets distributed to each and every one of those 20 million factors. So just keep distributing until each factor has that exponent that was on the outside of the set of parentheses. Notice in this example, the only thing I can do is this power of a power. I cannot distribute this exponent of 6 inside because this is a difference. The only way we're able to distribute that exponent inside a set of parentheses is if it is multiplication that is inside the set of parentheses. Well, here we have the same base being multiplied, only 2, and I added the 2 exponents. This last one, same base being multiplied, this time 3 times. Okay, then add the 3 exponents together. So again, using those properties. I am, in this first example, going to leave my answers as powers. I'm not going to actually evaluate them. If all I wanted was a numerical answer, I might as well just press buttons on my calculator and get that numerical answer that way. Instead, I want us practicing using those properties. So in number 1, 3 to the 4th times 3 to the 6th, I'm multiplying powers that have the same base. The product of powers rule tells us to keep the base the same and add those exponents. Therefore, that is 3 to the 10th. Number 2, 2 to the third, that quantity squared. Power of a power, I multiply those, so that's 2 to the 3 times 2, or 2 to the 6th. For number 3, you have a set of parentheses being raised to an exponent. It's either power of a power or it's the power of a product. Well, what's inside? It's a product. This is really 2 times x. So this exponent of 2 needs to be distributed to each factor. So I will have 2 to the second times x to the second. A little bit more going on in number 4. Start inside this set of parentheses. Usually we look to get rid of parentheses. No different now. So this 5 to the third will come with me. Well, I have a set of parentheses with an exponent outside. Inside the set of parentheses is a product. That really is 5 times a to the 4th. Therefore, this exponent, power of a product, needs to be distributed. So the 5 is now being raised to the second power. A, already to the 4th, power of a power, multiply, just like you did in number 2, 4 times 2. So if I clean this up a little bit, that A, 4 times 2, will be to the 8th. But now notice, I have the product of the same base. Add those exponents. So 5 to the 3 plus 2, or my final answer, 5 to the 5th times A to the 8th. So again, we have a few properties being used in that one. Actually, every single one of the properties that we discovered is used within there. I had the power of a product, I had the power of a power, and then I had the product of power. So all 3 of our properties are used within that one example. Next one there, I'm actually going to look at it 2 ways. The first way, I'll do it exactly like we did number 4. The 4x just going to come along with me. And now distribute. This is a product with a power on the outside. So that power gets distributed to each factor. So x now has an exponent of 2. This is now x to the third to the second. Power of a power we multiply. So 3 times 2 would be 6. And now notice, I have 3 same bases. This is really 4 times x. You can separate those. You don't have to physically separate them. If you separate them in your mind, that's good. Well, this x is to the first power. I have x to the first times x to the second times x to the 6th. All of those are the same base with multiplication in between. We can add those exponents. 1 plus 2 is 3. 3 plus 6 is 9. Final answer then, 4x to the 9th. Now, I did mention that there was another way of doing that same problem. You could have, again, usually we start inside a set of parentheses. Well, look in this parentheses. This 4x coming along. But I can put these 2 x's together. X to the first times x to the third is x to the 4th. Use your product of powers. That 2, our squared, is still on the outside. I didn't do anything to get rid of that set of parentheses. Well, now I can do power of a power, 4x, or 4 times x still coming with us, times then power of a power, multiply. And then the last thing, I have x to the first, x to the 8th, the 4 just comes with us, would be that x to the 9th. Same final answer, either way of doing that is perfectly fine. Jumping up there then to number 6, power of a power. We are going to multiply those. So power of a power multiply, 12 times 5 is 60. So w to the 60th. For number 7, there's really no reason for this negative ab to be in a set of parentheses. That's really the opposite of a times b. The only reason it's in parentheses is to separate it from this other one. But this other set is in parentheses because it has this exponent of 2. This is a product, therefore we need to distribute that exponent to each factor. So power of a power multiply, so 2 times 2 is 4, and then times b to the second. In my final answer, each base will be written only one time. Therefore, my A's can go together. Some people say, well, wait a second, this isn't A, it's the opposite. Well, what does that really mean? That really means -1 times A times B and all the rest. So think of that -1 separate. It doesn't have another plain number to go with, so it'll just stay -1. Now let's put those A's together. A to the first times A to the fourth. Product of powers, add those exponents, 1 plus 4, A to the fifth. And then we can do the same thing with our B's. This B is to the first power, and then we have 2 more, making a total of B to the third. Very similar in number 8, 2x to the third, remember really 2 times x to the third, times then 3x's in a set of parentheses. Remember this is really 3 times x, so this exponent of 2 needs to be distributed to each factor. So now I have 3 to the second times x to the second. Put together only like bases. 2 and 3 are not the same base. Therefore, those have to stay separate. I would leave that as 2 times 3 squared. I can't make that 6 to the second, 6 to the third, not even quite sure what you would do with that. They have to stay separate. It's only when the bases are the same. Well, here I do have bases that are the same. I have x to the third and x squared. Add exponents would make that x to the fifth. So again, notice unless the bases are the same, I cannot combine those, so those two would stay separate. For number 9 then, set of parentheses, because this exponent needs to be distributed, it is a product, so I will have 3 to the third times b to the third times another b. That b is really to the first. 3 to the third doesn't have another base of 3. B to the third times b to the first, b to the fourth. And the last one looks a lot worse than it is. Start inside that set of parentheses. 5 plus x, can't do anything to that. My exponent, can I distribute it inside? No, and why not? Because it is a sum. The only way we can distribute an exponent inside a set of parentheses is if it is a product. Multiplication being done inside the set of parentheses. Therefore, this 5 plus x must remain in a set of parentheses. The only thing we can do is this power of a power. Power of a power tells us to multiply. I have 6 copies of this quantity to the third. That makes 3 copies of the 5 plus x, giving us a total of 18 copies of that 5 plus x. Again, you cannot distribute that 18 inside. This is a sum. Can't distribute an exponent to a sum or difference, just a product.